Let's take an example which is shown on your page number 2 of your book. So we'll take two equations, linear equations with two variables, let us say 5x. So there are two equations, 5x minus 3y is equal to 8. So this is the first equation. And there is a second equation, 3x plus y is equal to 2. So this is the second equation. So if you look at these equations, there are two variables x and y. This is the first equation. It is the same variables and another equation. So there are two equations and there are two variables. So we can solve this one. So first we will see by elimination method. So elimination method मध्ये आपण सिंपल थोडं तुम्ही लॉजिकली विचार केला, जर तुम्ही काही न्यूमेरिकल जर सॉल्व केले असतील तर ते खूपच इझी आहे. इनफॅक्ट हा चॅप्टर्स खूप इझी आहे. See, here is 5x minus 3y is equal to 8 and 3x plus y is equal to 2. When we say elimination method, म्हणजे या दोन इक्वेशनचा वापर करून आपण यातला एक व्हेरिएबल इलिमिनेट करायचा, सबट्रॅक्ट करायचा. म्हणजे we have to get one equation such that there is only one variable will be left out. म्हणजे या दोन व्हेरिएबल मधला एक व्हेरिएबल इलिमिनेट व्हायला पाहिजे आणि एक व्हेरिएबल राहायला पाहिजे. आणि जर आपल्याला असं इक्वेशन मिळालं की जे एक व्हेरिएबल आहे आणि एक इक्वेशन आहे, then we know answer of that equation is minus b upon a. Correct? चलो करते हैं. So here is minus 3y plus y. So I'll write down here multiplying equation 2, or I'll write down like this way, equation 2 with 3. या 3x plus 2 हे दोन नंबर इक्वेशन ला 3 ने मल्टिप्लाय करू. सो इट विल minus 3y plus 3. तर आपल्याला या दोघांची 3y व्हॅल्यू मिळू शकेल. सो मल्टिप्लाइंग इक्वेशन नंबर 2 with 3 we get समजा याला 3 ने मल्टिप्लाय करा आपण, तर what we'll get 3 that is equal to 9x plus 3y. Here also multiply 2, so 6. So this is what we got third equation. Actually, in fact, it is the same equation. We have just multiplied with 3. Now we can take the first equation here. So that is equal to 5x minus 3y is equal to 8. That is the first equation. If you look at this equation, it's a plus 3y minus 3y. So if we add these two equations, then plus 3y minus 3y, these terms will get cancelled and you will get only one equation. So let's do that. So by adding equation 1 and 3, so I will do like this way, plus. So 9 plus this is equal to 14x. This will get cancelled, so it will be nothing will be left out here, and 8 plus 14. So this is I got the fourth equation. So now it is in the form of one linear equation with only one variable. So I can get x is equal to, I'll take this 14 on this side. So 14 divided by 14, I'll get the answer 1. So I got this first answer of variable x is equal to 1. If I put this value in any of the equation, then that equation with two variables putting this value of x in equation. कोणत्या इक्वेशन मध्ये आलो आपण? So let us put it in the equation number 1. In equation 1 we get काय मिळतं बघूया आपल्याला. What we'll get? So we'll get, I'll write down here because I have a short of space. Space is short, so I'll write down here. So what I'll get 5x. X value किती आहे? X value 1 है. So I'll put it here. 5 into 1 minus y is still unknown, so 3y, right, is equal to 8. So from this, I can take 3y on this side, 8 on this side. So I'll get it minus, this minus will become 3y here, this 5 will be here, and this 8 will come here, minus 8, right? So I'll get the y, so here I'll get minus 3 is equal to 3y, so I'll get y is equal to minus 1. I'll get y is equal to minus 1. So we got the values of the two unknown x and y, so we can write down, so x and y is equal to, in the ordered manner, x is equal to 1, x is equal to 1, and y is equal to minus 1. So this is how we have solved this simultaneous equation. It's very simple. We have eliminated the term by multiplying one of the equation with proper values so that one term will get eliminated. So this is called as the elimination method. So out of this, what we have to learn, if you have one unknown, one equation is enough. If you have two unknown, we require two equations. Keep it in mind, this is a very useful funda that will require 11th and 12th as well. So now I will rub this out. Substitution method, yes, you can do by substitution method. You can go into your book and you can refer the substitution method because this is already you have done in 9th standard. Okay, let's take one more example. उतार लो. Solve 3x plus 2y is equal to 29. This is the first equation, and second equation is 5x minus y, and that is equal to 18. So this is the example. This is the first equation. This is the second equation. So as you see on the board, there are two linear equations with two variables. So it's quite simple. So you can, here you see plus 2y, here you see minus y. So you can add, you can multiply this second equation with 2. So you can write down here, multiplying by 2, we get, so if we multiply here, we'll get this 10x minus 2y, 18 to the 32, so that is the third equation. So here is minus 2y, so plus 2y. If I add 1 and 2, so I'll write down here, adding equation 1 and 3. Now it's a 3 equation. And 3. Right? We get. So here if I add it, I'll bring it here. So I'll do like this way. Make it 3x plus 2y is equal to 29. So this will get cancelled. So I'll get 13x is equal to 61. So it's a 36, sorry. This is a 36, I made a mistake. This is 36. 36, sorry. So this is a 29. So I'll get this one as 65. So that's right. So x is equal to 65 divided by 13. So I got, so 13 into 5 is equal to 65. So I confused with this one because of the odd 13 number. So x is equal to 5. So we got the first value of x is equal to 5. Now I will substitute this value in one of the equation. So I'll see substituting value of x in equation. I can put the value in any one of these ones. So I'll put in the value of in the equation number 2. In equation 2 we get, right? So 2, so 5 into 5 minus y is equal to 18. So I'll take y on this side, 5 by 25, I'll take 18 on this side, so y is equal to 7. So I got another value, so here we get y is equal to 7. So answer of this two simultaneous equation is x and y, and that is equal to 5, 7. So that is the answer. So I think now you can solve these equations very well because you have already learned these things, and you can go back to the exercise and you can